This video is the second lesson in the Basic Algebra in Full series. To go to the previous lesson or to access all lessons in this series or playlist, check the video description or pinned comment. Happy studying. Hello and welcome back to Math in Full channel, where everything in mathematics is connected and truly understood. In lesson 1, we've introduced algebra and the idea of algebra. We've seen what algebraic expressions and equations are like. But we don't stop there. The next thing you are supposed to do is to simplify these algebraic equations and expressions. To simplify, the first step is to collect like terms. And it is not all the time you'll be able to collect like terms. So in this video, you will learn when it is possible to collect like terms and when it is not possible to collect like terms. You will also know those things to look out for before you attempt collecting like terms. Now let's begin. If you had 2 plus 3, an expression, though it is not algebraic but it's an expression, and you want to simplify it, what does it mean? It means that you want to make it shorter. So you want to replace this 2 plus 3 with 5. Why are you replacing it with 5? Because 5 is just one article compared to here that you have 3, 2 plus and 3. Another reason for simplification is to get an answer. So 2 plus 3 is obviously 5. So if you are given a question to solve and you stop at 2 plus 3, it's an inappropriate answer compared to 5 that is a more appropriate answer. So these are the reasons why we want to simplify an expression. And in algebra, it is no different. But because letters are involved, there are certain things you must bear in mind before you attempt to simplify. One of them is collecting like terms, and that's what this video is all about. Now just a quick recap before we go on. 2x and 5x are like terms. People who have watched lesson 1 know that this is correct. However, 2x squared and 5x are not like terms because one of the x has raised to power 2, the other one is just x, or x raised to power 1. Now let's introduce something that we didn't mention in lesson 1 but is relevant to mention here now. If you had 2x raised to power 2y and 5xy, then these are also unlike terms because the x here has raised to power 2, the x here has 1. Even though the y is raised to power 1, it already makes it an unlike term. So this is just a refresher. With this recap, we can now collect like terms, which is simply putting together those terms that are alike. That is, those like terms side by side as if they are neighbors, so that your simplification process will be much easier. You see this algebraic expression on your screen. Before you go ahead and simplify it, you have to pull together this 2x, this 5x, this 8x. You have to find a way of bringing them together and combining them. Same with this 3y and this y. Have to find a way of bringing them together and then putting all the other numbers together in order to simplify it. This process is what we call collecting like terms. So it's just like when you go to market and buy fruits, let's say oranges and apples, and put all of them in a bag. And then when you get back home, you want to count to know how many oranges and apples you have. To ensure you count them properly, you have to first of all pull all the oranges together in one place, pull all the apples together in another place, and then count the oranges and count the apples and say, I have this number of oranges and this number of apples. That's how it is in algebra, in collecting like terms. The only difference is that it is not apples and oranges, unfortunately. There are certain things you need to look out for before you are able to pull them together and add or subtract or do whatever you want to do with them. And that is exactly where we are going to next. Not knowing these things I'm about to talk about now is the major reason why most people still get collecting like terms or even solving algebra as a whole wrong, especially students. So please pay careful attention here. So I'm now going to go into those 3 things you must know before you pull these like terms together. The first one is what I call sign or operator ownership. What does it mean? It means that the operator or sign to the left of a number or a term belongs to that term or number. As an example, look at this expression on your screen. Here, this 3y is a term. This minus sign here is beside it. So this operator ownership I'm talking about means that this 3y owns this minus sign. So minus 3y is a unit. That's what this thing I'm talking about is. The second part of this law or this rule that I call operator ownership is that if a number or a term has no operator beside it, then the operator beside it automatically is plus. So look at this example here. This 7y, because it's the first term in this expression, it has no operator beside it. So automatically plus becomes its operator. So this is the first rule. You must know. It is very, very important to know this. The second thing you must know is what I call operator or sign siblingship or operator families. As you can see on your screen, we have two families we will talk about, the plus family and the multiplication family. The plus family has plus and minus. These plus and minus are siblings. Remember that. The multiplication family, we have multiplication and division, and they are also what? Siblings. Now, there are other members of the multiplication family, such as squares, roots, powers. We will encounter this in other lessons, but just important to mention that they are part of this family. But this is very, very important. You need to be able to distinguish that the plus and the minus operators are different from the multiplication and division operators. They are in different families, and it affects if you are going to collect like terms or not. So, what is this second rule saying? The second rule is saying that if the expression has operators that are all from the same family, then you can collect like terms and move them as you like. But once the operators are from different families, you cannot move those terms. Because once you move it, then it becomes mathematically incorrect. So this point is very, very important. This is one of the reasons why people find it difficult to simplify an algebraic expression, or they always get it wrong. Once you have plus and minus and multiplication, division all in an expression, you cannot just move terms anyhow you like. Even if all the operators are from the same family, but one is from a different family, then you cannot collect like terms. You cannot move any term. Otherwise, you stand a chance of making your equation or expression mathematically incorrect. Now, let's take an example to make it clearer. Now, look at this expression on your screen. We are going to apply the two things, the two laws we've talked about now. The first thing, to collect like terms, we have to identify them. 5y. Now we're identifying them with their operators. Remember what we said in the first rule. Then plus 3y and minus 4y. So if we want to collect like terms, we will say 5y, we take this next, plus 3y, we take this next, minus 4y. Then the other ones we come, minus 2 we follow, then plus 6 will now follow. So that's how we've collected the like terms in this particular expression. You see that it is pretty straightforward once you know these laws and you are able to apply them. Now let us look at something similar to this, but we now bring in the second law and see why we will not be able to collect like terms in that case. Now look at this expression on your screen here. 5y times 2 plus 3y divided by 6 minus 4y. There is no way you can collect like terms in this situation because the operators here are from different families. There's multiplication, there's addition, there's division, there's subtraction. You cannot collect like terms. The only way you can solve this is to use what we call order of operations or BODMAS or PEMDAS, depending on where you are studying. The US, Nigeria, UK, India, wherever, they call it different things, BODMAS, PEMDAS. And we will do that in further lessons. Just follow the series. We will get to BODMAS. BODMAS or PEMDAS or order of operations is the only way you can solve this kind of expression to simplify it. Otherwise, you cannot collect like terms. This is very, very important. The third and final rule that we are going to look at is what I call movement of terms. What does it mean? Let us take a look with this example on the screen. What we are saying in this third rule is that you can move a term from one side of an equation. That's if we are dealing with an equation. Remember the previous examples were all about expressions. But if you have an equation, an algebraic equation like this, and you want to move a term from one side to the other, you can, provided you've met the second rule we talked about, that if all the operators are siblings. As we can see in this example, they are all siblings. So if you want to move this plus 3y to this other side, you can, but you have to bear in mind that the operator here, we have to change to its sibling. So what are we saying? We are saying that we can move this plus 3y here, and when it gets to this side, it now becomes minus 3y. That's what we are saying. So if we wanted to rewrite this equation, it would be 5y minus 2 plus 6 minus 4y is equal to 0 minus 3y, which obviously is the same thing as 5y minus 2 plus 6 minus 4y is equal to minus 3y. Because 0 minus 3y is minus 3y. So this is basically the same thing as this. We've just written it in another way by moving the 3y from the left to the other side to make it minus 3y. This is the third and final rule you must know. Now, note that this thing I just did now is similar to what most people do in school. And they say, subtract minus 3y from both sides. Yes, it's exactly the same as what I just did now. But this is a bit better for me, especially trying to teach you. Is better this way, because if you have operators from different families and you are doing subtract minus 3y from both sides, you will definitely make a mathematical error. So just view it in the way of saying moving it with its operator rather than saying subtract this from both sides or add this to both sides. It's easier for you to learn that way. Now, there's one more thing that we are going to talk about before we now start taking examples to solidify what we've learned, which is just the conventions, the conventional or the standard ways of writing an algebraic term. If you had an algebraic term that has, say, variables a, b, or xy, let's use common ones, xy, so 2xy. Now, if you write 2yx, it's not incorrect, but it is just not standard or conventional. So the conventional way is write the letters in the way they appear in the alphabet. So if you had 2yx, it's better to write it as 2xy, just to make it conventional worldwide. This is obviously when you are creating your own algebraic expression or equation, maybe from a word problem. So you rather write 2ab instead of writing 2ba. It's better you write 2x square y or 2xy square instead of writing 2y square x. So that is just to mention it in case people didn't know. So we are going to wrap up the video now by taking a few examples. I don't want the video to be too long, but I'll try to take 1 or 2 examples, then give you your try exercise before we go. Note that since we've started so far, we've not even gone into addition and subtraction of the terms themselves. We are still collecting them because these laws are important, or these rules. Let me just say my rules. They are important before you can collect. That's why we are taking time. We've not done addition and subtraction. Addition and subtraction will come in the next lesson. For now, we are still trying to collect like terms. So let's quickly look at this example. Let us collect like terms quickly here. So first, identify the terms. After confirming they are all siblings, as you can see, all the operators are from the plus family, so we are okay to collect like terms. 12a, a is in it. Minus 8a, there's a here. There's no other a. So if we are going to write, the first thing we'll write to be 12a minus 8a. Then again, for the b, we have plus 5b plus 3b. So it will follow next. Plus 5b plus 3b. Then what is left? Minus 7. So this is how you collect like terms for this expression. Let's take another example. Now, example slightly harder with powers. X squared, the first term has x squared. So this, the other term has, this is another one with x squared. That's all, no other x squared. So we'll write minus 2x squared, then pick this one, minus 3x squared. Then the next one is 5x here. Sorry, plus 5x. Let me not forget the operator. Minus 8x. So that's the next one we will write. Plus 5x minus 8x. Then what is left is plus 9. Let's take another example. Okay, now this is a slightly harder one. So the first thing we'll do, we look at all the operators. Are they siblings? Yes, they are all siblings. Just plus and minus. The next thing we will do is to now start grouping the terms. The more you do this, the faster you get, because you'll be able to do it in your mind, or just as you are writing it, you'll be doing it. So, but since we are still learning, let's take it slowly. So the first thing we are seeing here is 4x raised to power 3. So we scan through. Any other x raised to power 3? Yes, there is. This is another one. Any other one? No, no other one. So we'll first write this. 4x raised to power 3. Obviously, we are taking the plus. I always forget to put this because I'm used to writing it very fast. Sorry. 7x raised to power 3. So we identify the next one. So the next one here is minus 6x squared y. So we have to look for other terms that have x squared y. X squared y. This is xy squared. It's not the same here. It's not the same. X squared y. Yeah. So this is another x squared y here. Is there any other x squared y? No. No other x squared y. So we are going to have to follow up with this. Minus 6x squared y. Then plus 2x squared y. So we've done 2 now. Let's pick the next one. Next one is plus 9xy squared. So any other term with xy squared? Xy squared. Yes, this one has xy squared. So that's the next one we'll pick. So we say plus 9xy squared minus 5xy squared. Then what is left? We have this left, and this left. So we just complete it. Minus 3y raised to power 3 plus y raised to power 3 minus 8. That's all. Very easy. So let's take another example. One more difficult, obviously. Now look at this one on your screen. It's quite difficult, I know, quite complicated. So you are told to collect all the terms with x squared y and xy on the left, and then y squared, a, b, and numbers on the right. So because we are still learning, let's first of all move all of them using our rules. Then after moving them to where they ask us to move them to, then we can now collect them properly. So let's first identify all the ones that are supposed to be on the left, which is x squared y and xy. So this is x squared y, this is xy, this is x squared y, this is xy. That's all. So 2 on the left, 2 on the right. So the ones on the left are already on the left. The ones on the right need to be brought to the left. So to bring them to the left, we have to, so let's start writing so that we don't waste time. So the ones that are already on the left, 6x squared y minus 4xy. So these 2 here that are on the right, we have to pull them to the left. So to do that, remember what we said, the sibling, it will have to change to each sibling. So this minus becomes plus and this plus becomes minus. So we have plus 2x squared y minus 7xy. So that is that for those on the left. Then all the other ones that we didn't circle are going to be on the right, obviously, since they are the second part of the question. So we just go ahead with equal to. Now, let's not make mistakes here. Which ones are already on the right? Because their signs will not change. The operators will remain the same. These are the ones already on the right. So we'll put them first. Minus 9y squared minus 3ab plus 12. Which are the ones coming from the left? All these ones. So all their signs will change. Starting from this plus 3y. So plus 3y becomes minus 3y squared. Sorry, I said 3y, instead of 3y squared. Plus 8b becomes minus 8ab. Then minus 5 becomes plus 5. Now for the second part of the question, let's now collect the like terms. So this will be easy. X square y here, x square y here. So that gives us 6x square y plus 2x square y. Then we put the remaining one here, minus 4xy, and this one, minus 7xy. Then on the right, we will have, collect it again, minus 9y squared, minus 3y squared. So that becomes minus 9y squared, minus 3y squared. Then collect these ones as well, minus 3ab and minus 8ab. So it becomes minus 3ab minus 8ab. Then we put the remaining numbers, plus 12 plus 5. Simple. I know these numbers and terms and everything look so much on the screen. The idea, what I'm trying to do, is to make you master collecting like terms. So that's it. Pretty easy. Here is the try exercise for this lesson. We have so many we could have tried, but there is no time. So follow us on all social media platforms and on our website as well to get some of these exercises, more of them. As usual, we will put the solution to this. Just keep an eye on the channel. But after you've tried it, don't check the solution before trying it, okay? So this is where we draw the curtain on lesson 2 of basic algebra in full. Use the comment section for your comments, clarifications, or questions, or you could also mail us at ask@mathinfull.com. Visit our social media handles, follow us, visit our website. So many things for you to check out there and continue your learning. And while you study, remember, in mathematics, it's all connected.